Hi there, welcome back. This is part two of our discussion of Caribbean geology. Here we will talk about the Caribbean tectonic plate and the geological historical development of the Caribbean area. Well, our next topic is a discussion of the Caribbean tectonic plate. I would say that the plate tectonics and structural development of the Caribbean area has been discussed by many good scientists, various authors. Uh, the ones that have been most significant in my research are listed on this slide. And remember that in part 13 of this overall presentation, I have all of the key references that I have used. And all in all, there are over 50 references. Well, the Caribbean tectonic plate is an oceanic plate underlying Central America and the Caribbean Sea, uh, lying on the north coast of South America. With an area of about 1.2 million square miles, the Caribbean plate borders the North American plate, the South American plate, and on the west, the Nazca plate and the Cocos plate. Obviously, plate boundaries are regions of seismic activity and volcanic eruptions, and this is no exception here. The northern boundary of the Caribbean tectonic plate uh, is highlighted here by the red pointers. Uh, this northern plate boundary with the North American plate is a transform boundary, or if you will, a strike slip fault, which runs from the border area of Belize, Guatemala, and Honduras in Central America uh, eastward through the Cayman Trench. Part of the Puerto Rico Trench, which is, by the way, the deepest part of the Atlantic Ocean with a water depth greater than 27,000 feet, lies along this border. Now, the eastern plate boundary is where the action is. uh, this is a subduction zone where oceanic crust dives beneath the Caribbean tectonic plate. That boundary is highlighted on this slide by the orange pointers. Uh, Subduction at this convergent boundary forms the islands of the Lesser Antilles volcanic arc, uh, located between the Virgin Islands on the north and the islands of the Venezuelan coast on the south. You know what? 17 key active volcanoes are part of this arc. The most notable uh, are Soufriere Hills on the island of Montserrat, Mount Pelée on Martinique, La Grande Soufriere on Guadeloupe, Soufriere Saint Vincent on St. Vincent, and the submarine volcano Kikemjeni, about 10 kilometers north of Grenada. The southern plate boundary is shown here by the light brown pointers. Uh, Listen, this is a mess. It is geologically very complex, where the Caribbean plate interacts with the South American tectonic plate, forming, by the way, Barbados, Trinidad, and Tobago, as well as the islands of the coast of Venezuela and Colombia. This boundary is a combination of transform faulting along with thrust faulting and some subduction. Finally, we come to the western boundary. Uh, I will say that the western portion of the Caribbean tectonic plate contains Central America. The Cocos plate in the Pacific Ocean plunges beneath the Caribbean plate along the western coast of Central America. This subduction zone forms the Central America volcanic arc and accounts for the uh, volcanoes that we find in Guatemala, El Salvador, Nicaragua, and Costa Rica. So definitely an active zone. Okay, what about a sequence of geological historical events for the Caribbean area? I will tell you, Silly in 1992 has a very good summary of this. Uh, the Atlantic Ocean opened at the end of the Triassic as the North American tectonic plate rotated away from South America and Africa. In turn, by the way, the Yucatan area moved into the Caribbean region, creating the Gulf of Mexico. Closer to the Atlantic Ocean, a long and tapering sedimentary wedge was deposited in shallow waters, forming the Florida, Bahama, Cuba platform. These movements continued until Cretaceous time. At this point, Central America, as far down as Guatemala, looked pretty much like it looks today. In addition, South America had started to move westward, opening the South Atlantic Ocean. Both the North American tectonic plate and the South American tectonic plate were diverging and drifting westward, creating an ever increasing gap between them. And then guess what? A section of the Pacific tectonic plate moved in to fill in this gap. In doing so, the Caribbean tectonic plate came into existence. A convergent boundary and the subduction that goes along with it developed and resulted in volcanic activity and the creation of the Greater Antilles. Initially, the Caribbean tectonic plate moved eastward and northward, pushing towards Cuba and the Bahamas. By the end of the Cretaceous period into the Paleocene epoch, subduction activity stopped in the area of the Greater Antilles, and by Eocene time, or the Eocene epoch, the subduction began in the Lesser Antilles. You know what? At present time, the Caribbean plate is moving eastward at a rate of about 22 millimeters per year relative to the South American tectonic plate. And relative to the North American tectonic plate, the Caribbean plate moves east-northeast at about 20 millimeters per year. Silly in 1992 points out that the Caribbean plate presently actually moves very slowly to the southwest, but it is overtaken by the motion of both the North American plate and the South American plate. So relative to these two plates, the Caribbean plate moves in an eastwardly direction. We believe that plate migration started in the late Cretaceous. Now, pertinent to its genesis, there are two theories that account for the development of the Caribbean tectonic plate. The first theory sees the Caribbean large igneous province originally forming in the Pacific Ocean. But a second theory describes the Caribbean plate as developing from an Atlantic hotspot that is no longer in existence. Now, Seeley in 1992 has a real good summary of the sequence of events in the Caribbean area. Starting in Cretaceous, the Caribbean plate broke away from the Pacific plate. The islands of the Greater Antilles formed as a volcanic chain as a result of the subduction zone that developed in this area. In the Paleocene, the Caribbean plate started to move eastward, resulting in orogenic activity in the Greater Antilles, as well as Trinidad and in Venezuela. In the Eocene, uh, subduction and the volcanism that goes with it came to an end in the Greater Antilles and began full steam ahead in the Lesser Antilles. In the Oligocene epoch, the Bahamas, Belize, and much of the Greater Antilles area became shallow water banks fringed by coral reefs. By the Miocene epoch, Jamaica and Trinidad rose above sea level. In the Pliocene, the margins of the Caribbean tectonic plate were underthrusted and uplifted, and the western Leeward Islands of the Lesser Antilles were formed due to volcanism. And in the Pleistocene to Holocene time frame, the islands of the Bahamas were formed while Barbados and the Limestone Bank Islands took their present shape. Well, this concludes part two, so let's go into part three.